Okay, so in the last video, we discussed quadratic inequalities, and in this video, I want to go over in a little bit of detail polynomial inequalities. So these are just even a more general version of the quadratic inequalities. Now we're discussing inequalities of just general polynomials. Okay, so these are all going to be examples where we should be able to at least fairly nicely factor the polynomial. So these will not be the perfect generalization of it, but it will be sufficient for this class. Okay, so it shouldn't get too much more complicated than anything you're going to see in this section. So this is one of those subjects that takes a little bit of time and a little bit of practice. So I would really encourage you to go on as soon as possible on Alex and just dive into this and see if you can get some experience with it. And I would also review these for the final because these often show up on tests. They're very good to test. This is a very good problem to give you to test all sorts of different knowledge because it's applying a lot of different aspects of knowledge that's taught in this class. So I would really encourage you to get familiar with these. So let's go ahead and jump right in. Here we have the polynomial x squared minus 4 times x plus 4 times 5 minus x. So we'll notice right away that we're going to have a degree 4 polynomial. That's because if we multiplied all of these together, our leading term would be something along the lines of x to the 4th. Okay, so that means we should potentially have four zeros as well. Okay, so let's go ahead and see what these zeros are going to be. So first of all, we can notice that x squared minus 4 can be factored a little bit more. Okay, that's a difference of squares. So remember, if we have a squared minus b squared, we get a plus b times a minus b. So this will become x um, x plus 2 times x minus 2. Okay, right? So if we have, remember, if we have, that'll give us x squared minus 2x plus 2x. Those would cancel, and then we'd have minus 4. Okay, so there's that. And then we have x plus 4, and then we have 5 minus x. And this whole thing is going to be greater than or equal to 0. Okay, so that's how we're going to rewrite that. So what we're going to do now is we're going to notice we're going to find all of our intervals, okay, and we're going to do test values on each of these. Okay, so we have issues here at each, not issues. We have our points of interest that divide these intervals for all of the zeros. So if we look at all of the zeros here, we're going to have -2, we're going to have +2, we're going to have -4, and we're going to have 5. So these are going to be our dividing points, so to speak. So that's going to give us, we're going to make a table here. Okay, this is our interval section here. So we're going to have the interval from -infinity to -4. That's our furthest left point. Then we're going to have the interval from -4 to -2. Then we're going to have the interval from -2 to +2. And then we'll have the interval from 2 to 5, and the interval from 5 to infinity. Okay? And then we're going to have something called a test value. Okay, we kind of discussed this a little bit in that last video, but test value. Okay, and then we're going to have, also going to have their product too. That's important. Okay, test value. Then we're going to have the actual value, and then we're going to have the sign. Okay. Let's give ourselves a little bit more room here. Okay, so let's go ahead and get started. Okay, so if we look at the interval from -infinity to -4, let's pick a test value here. I just like -5, I guess. It needs to be strictly less than -4. You can really use any value you want that's within that interval. So I like to stick to whole numbers where that's convenient. So we'll say -5. So if we plug in, let's say, we'll have, what we're going to do is we're going to plug in -5 for each of these terms up here. Okay, so we'll have -5 plus 2 times -5 minus 2 times -5 plus 4 times -5, sorry, 5 5 minus negative 5, okay? This is going to get, if we, let's see, we need a little more space here. Move all this over. Okay. This is going to give us, negative 3 times negative 7 times negative 1 times 10. Okay, that's going to give us negative 210. So our sign here is negative. Okay, maybe the easier way to do this would be, let's actually just think of a faster way to do this. We don't necessarily have to plug in the exact value and find the exact number. What we can do is we can just acknowledge, okay, if we pull a value from here, what would each of these be? So we would have, okay, if we plug in negative 5 for x plus 2, that's going to give us, negative 5 plus 2 is going to be negative. Negative 5 minus 2 is going to be negative. And then we'll have negative 5 plus 4, that's negative again. Okay, and then 5 minus negative 5, that'll be positive. So that'll be times a positive number. Okay, so we'll have a negative times a negative, which is a positive. So times a negative again, which is negative, times a positive, which is negative. So our sign here is going to be negative. And so we're looking for all of the values that are, all of the intervals that are greater than or equal to 0. So we can go ahead and exclude this value here because it's going to be negative. Okay, so now let's check from negative 4 to negative 2. I like negative 3. So if we have negative 3, we'll have negative 3 plus 2. That's negative. Okay, and then we'll have negative 3 minus 2. That's positive. Okay, and then we'll have, wait, hold on. We have negative 3. Okay, negative 3 plus 2 is, sorry, I made a mistake here. Let's back up. We have negative 3 plus 2. That's going to be negative. Okay, negative 3 minus 2. That's negative again. Negative 3 plus 4. That's positive. And then 5 minus negative 3. That's going to be positive as well. So we'll have negative times negative, which is positive, times two positive numbers, which is going to be a positive number. So we're going to have this be one of our intervals here, negative 4 to negative 2. Okay, so what we can do is, remember this for the end here. Just find a way to remember which ones we're going to use in the end here, right? So we'll have negative 2 to 2. I always like 0. 0 is always a really good choice here if you can find 0 as part of your interval, if you're able to do that. So we'll have 0 plus 2, that's positive. 0 minus 2, that's negative. 0 plus 4, that's positive. And 5 minus 0, that's positive. So we have positive times negative, which is negative, times positive, which is negative again, times positive, which is negative again. So this will be negative, okay? And we're looking for greater than or equal to 0, so negative 2 to 2 is not part of our solution. Okay, how about 2 to 5? I like the point 3. So if we plug in 3, we have 3 plus 2, that's positive. 3 minus 2, that's positive. 3 plus 4, that's positive. And then 5 minus 3, that is positive again. So this will be positive, and this will be part of our solution. So for 5 to infinity, now we have, we can try 6. Okay, so if we have 6 plus 2, that's positive. 6 minus 2 is positive. 6 plus 4 is positive. And then we have 5 minus 6, that's negative. So we have positive times positive times positive, that is going to be positive, times a negative is negative. So this will not be part of our solution. So the only intervals we have to worry about are negative 4 to not worry. Only intervals we have to consider for part of our solution is negative 4 to negative 2 and 2 to 5. However, we also want to find the points where it is equal to 0. And that means we're just going to include the endpoints of these intervals as well. So we're going to have the closed intervals from negative 4 to negative 2. And we're going to union this with the interval for the closed interval from 2 to 5. And that would be our solution for this polynomial inequality. Okay, let's try this one. Here we have x minus 8 squared times x squared plus 1. Okay, so first of all, let's look at our zeros here. By the way, this is less than 0. Okay. So our zeros are going to be, looks like 8. Okay. And then we're going to have, we're not going to have any zeros here for x squared plus 1. That's always going to be positive, okay? Because we can't have, if we plug in any number, if we plug in 0, then we're going to have 0 plus 1. If we plug in -1 for x squared, we'll have positive 1 plus 1, that's positive. And obviously any positive will make it positive as well. So really our only 0 is going to be 8, okay? So we plug in 8, we'll get the whole thing to be equal to 0. So let's see what happens here. So we have a 0 with 8, so that means we have to consider, let's look at our interval, let's look at our test value. Okay. And then we'll look at our sign. Okay. So we'll have the interval from -infinity to 8, and the interval from 8 to infinity. Okay. So if we plug in, I guess we can include products as well. Okay, if we plug in a value, test value, let's try maybe negative, well, let's do 0, because we include 0 here, right? Plug in 0, we'll get 0 minus 8, which is -8 squared, and that's going to give us a positive number, because if you square a negative number, you get a positive number, and then we said everything for x squared plus 1 is positive, so we will have positive, okay, times a positive, which means the sign is positive. And let's try 9 for 8 to infinity. If we have 9 minus 8, that's going to give us 1. Square root of that is a positive number, and then we said everything is positive for x squared plus 1, so it will have a positive times a positive, which is a positive. And this is an interesting situation because we want to find the intervals that make this less than 0, and we know that the behavior is going to be the same in terms of positive and negative, at least, on -infinity to 8 and from 8 to infinity. So we have sort of an issue here, right? We have sort of an issue here. The issue is that it's never going to be negative, and therefore we're going to say that there is no solution. There's no solution here. If it's never going to be negative, then we have to say there is no solution. Okay. All right, let's do one more. Here we have x to the third minus 8x squared minus 15x. Okay. So remember, if we want to try to factor this, we have to first set it equal to 0. So let's go ahead and move 15x to the other side. And that's going to give us x to the third minus 8x squared plus 15x is strictly less than 0. Now you'll notice right away that we can factor out an x. So that's going to give us x times x squared minus 8x plus 15 is strictly less than 0. And I think we can factor x squared minus 8x plus 15. So this will become x times two factors here, right? So we need to find two numbers that multiply together to give us 15 and add together to give us -8. Okay, so multiply together to give us 15 and add together to give us -8. So I'm thinking, let's see, -5 and -3 should do the trick. So -5 times -3 gives us positive 15. -5 plus -3 gives us -8. So we have x minus 5, x minus 3, and that should do it. It's less than 0. Okay. So our zeros here are going to be 0 for just x. If you plug in 0, we're going to get 0. And then if we have 5 and then 3, these are all going to give us 0. Okay. So our intervals are going to be from negative infinity to 0. We're going to have a 0 to 3. We'll have 3 to 5. And we're also going to have 5 to infinity. Okay, so let's go ahead and set this up. So we'll have the interval, we'll have the test value, and then we're going to have the sign. Or well, I guess we'll do the value and then the sign. Okay, so we have the interval from negative infinity to 0. We have 0 to 3. We have 3 to 5. And we have 5 to infinity. Okay. Alrighty, so if we pull a value from negative infinity to 0, let's try negative 1. Okay. So what we're going to do is we're going to plug in negative 1 to each of these and see what the product will be. So we'll have negative 1 times, so we'll have a negative number, times negative 1 minus 5 is going to be a negative number. And then negative 1 minus 3 is going to be a negative number. So that means that the negative number times a negative number, which is positive, times a negative number again, which means we're going to have a negative number. Okay, and we're looking for everything less than 0. So this will be one of our part of our solution. Okay, now we'll test from 0 to 3. So if we plug in 1, we'll get 1, which is positive, times 1 minus 5, which is negative, and then 1 minus 3, which is also negative. So we'll have positive times a negative, which is negative, times the negative again, which is positive. Okay, and since we're looking for everything less than 0, this is not going to be part of our solution. Okay, now if we examine the interval from 3 to 5, we can choose 4 as our test value. So we'll have 4 times, well, 4, which is, we'll start with just 4, that's positive, times 4 minus 5, which is negative, times 4 minus 3, which is 1, which is positive. So we're going to have positive times negative, which is negative, times positive again, which is negative. So this will be a part of our solution. Okay, and then if we choose the interval from 5 to infinity, we can choose the value 6. Choose the value 6. So we'll have 6, which is positive, times 6 minus 5, which is positive, times 6 minus 3, which is positive, and therefore we're going to be positive. And that means 5 to infinity is not part of our solution. And so therefore, we are going, since it's strictly less than 0, we're going to have the open intervals from negative infinity to 0, union with the interval from 3 to 5 as part of our actual solution here.